Thank you everybody for joining this Building an IoT app in 20 minutes with Helium and AWS IoT. My name is Mark Phillips. I run business development here at Helium, and we've got with us today Louis Thierry, who is a member of our developer engineering team and spends pretty much all his time building tooling and software and documentation and other resources for developers who are building applications on the platform. So he is really a fantastic resource for anybody who's trying to build an application on top of Helium. And I've asked him to join us today and build an application or demo building an application for using what we just shipped in the way of an AWS IoT Core integration on the platform, and specifically inside of the Helium console. So what we're going to do today is four short things. So I'm going to do a quick what is Helium overview, because sometimes people join these things and haven't actually had too much time to get sort of into the platform. I'm going to kick it over to Louis, and he's going to demo this app that he's built, which is, I'll let him tell you about it, of course, but it's a button press app using the ST Discovery board and AWS IoT and Lambda and Twilio. So all sorts of interesting services involved. We just launched this thing called IoT for Good, a contest that we're doing with Semtech and ARM and the group at Hackster to build solutions on top of the Helium platform that help defeat COVID-19 and any other sort of causes that are happening right now. And I'll talk about that briefly, and then we'll do Q&A at the end. So if people have questions sort of along the way, why don't we just have you drop them inside the chat box here inside of Zoom, and I'll pick them up after the whole presentation, or if there's a good spot for me to interject them as Louis is presenting this application, I'll do that as well. But feel free to put anything in there, and like I said, I'll pick it up after the talk. So without further ado, I'll just jump into, oh man, this is sad. So Peter Main, our designer, built this glorious keynote transition in between this hotspot and the next set of hotspots. Sadly, I couldn't get the keynote configured correctly, so I'm using preview. I'm sorry, Peter, when you see this. So for those of you who are not familiar with Helium, we have, over the last 6 months, built what is the largest public LP WAN in the United States. So we didn't start deploying hotspots, and this is a hotspot pictured here, until roughly August of last year, and we started in Austin, Texas. And since then, the Helium community, so Helium is a network that's deployed and managed by people. The Helium community has deployed over 3,300 hotspots across the United States to produce what I just said was the largest public LPWAN, and LPWAN is a low power wide area network, and specifically the largest public LoRaWAN network in the United States. So we're in over 800 cities at this point, all 50 states, and things are actually starting to pop up outside of the United States, which is interesting because these hotspots are not approved to run outside the US. But we will soon start doing our international expansion. We're live in Canada, and we're about to start publicizing the ability to turn any LoRaWAN gateway into a Helium compatible gateway. And actually, Travis, who's on this call, has worked pretty heavily on that alongside Louis, actually, in our engineering team. So that's pretty cool stuff. So what we're going to demo today is really how you make use of all that coverage, right? We spent 2019 proving that you could build a decentralized, people-powered wireless network. And like I said, we have the biggest one in the United States. We're growing globally. And that's great. But what do we do with all this coverage, and how do we actually make it valuable? So Louis is going to demo what is the core functionality of the Helium platform, which is to get data from a device, a sensor, something connected to the internet, a small computer, back to a web-based application and make actual use of the data. So what he's doing really ties together the reason for Helium to be here. And so with that, I will kick it over to Louis to talk about his application. But briefly, this is the architecture that we're going to see today. So IoT device, in this case, it's going to be this ST Discovery development board and the push button functionality of that board, specifically talking to the Helium network, which of course is a LoRaWAN network. Anything that uses LoRaWAN 1.0.2 can talk to the Helium network. This is routed through a hotspot. In this picture, you can just envision that hotspot as the entire network of hotspots. So anywhere on the network where you have coverage, and you can go to network.helium.com and see where all our coverage is. Any device can talk to the Helium network. Doesn't matter what hotspot it is. They all run the same firmware. They all accept the same version of LoRaWAN packets. From there, it gets pushed to the Helium cloud, which we call Helium router. And that's going to be using the Mqtt integration to talk to AWS IoT. And then from there, we talk to Lambda, which is just the ability to run functions on AWS. And lastly, to tick off one more buzzword here, we'll use Twilio to send a text to Lewis's cell phone when the button is pressed. So how's that sound for a setup, Lewis? You ready to go?
Yeah, absolutely.
All right, cool.
Let me, so I take control of the screen.
I think you just click
Share.
the bottom center
right.
of your host.
I think I'm driving now. All right, cool. So yeah, thanks for that summary, Mark. What I kind of am hoping to highlight with this demo is I think this AWS IoT integration we have is super powerful because it just doing apps there quick and dirty is super simple, and that's what you'll hopefully experience today. I'll start with, we're kind of going to work through the whole data flow, starting with the firmware. We're going to kind of set the whole flow up, and what I like about it is it's pretty easy. So we're using this Disco here. You don't need the sensor board, but obviously if you have this, you can do lots of more interesting alert type stuff with the same exact architecture. But basically when I press, I don't have video today, but I'm going to be pressing this button and hoping to get a text message when that happens. Well, not hoping, it's going to happen, you'll see. Anyway,
I was going to say there's no hope involved.
Yeah. Anyway, so let's start with, actually I'll start with the firmware. So all this code that I'm going to be using today is on our GitHub under helium.com longfire Arduino. If you go down, this is the part number of this Disco board from ST. And I have this longfire US button directory, which has all of the code that you need for this. So I'm going to just grab this stuff, which is the entire application that runs on the Disco. It's very close to the example that we already have in the LMIC library. Actually, I'll show you where that is just in case you're not familiar. But the first time you send a packet ever, to keep things really simple, after you've installed the LMIC library, there's this thing right here, and that's almost exactly what this code is. The only difference about this code is I've added a little bit of logic here to catch the button press. Actually, it starts with here. I configure the button. This makes it so that when the button gets pressed, this interrupt fires, and I set this Boolean. And when the Boolean is set in this loop here, I will do this send command. And then this send function, async send, sends a payload that has a 1. Otherwise, every 15 seconds, there's this heartbeat payload that I'm sending with a 0. And usually with these LoRaWAN alert situations, sending out a heartbeat, letting the user know that the sensor is alive and well helps. 15 seconds is a little bit aggressive, but it's just a demo. So anyway, that's the app. When you copy paste it in here, there's all you really got to do is fill in these credentials. So I'm going to go, you get these from Helium console. We're going to do that real fast. Button alert. You can set these to whatever you want. I'm going to go ahead and just use whatever the console generated for me. So the device EUI and the app EUI, in case you're not familiar with these, basically it's the address or the unique identifier of your device. Usually people use app EUI to indicate a type of sensor. So like all your temp sensors might have the same app EUI, and then within the application, you might have unique identifiers for each device that is a temp sensor. But you can more or less use these however you want. You don't have to do it that way, but anyway, so I put in the dev EUI, and I kind of did it without mentioning it, but you want to make sure you flip the data around to be a little endian for these EUI fields at least. And then the app key, you don't need to flip that one. So that's all the customization you need for this app. So I'm going to go ahead and start uploading that. And so when I'm uploading to a device, actually, let's see if I can do this. So I see that the device tried to join, and then I get this stuff that comes out, which is basically saying, hey, I joined, I got the answer from the server, and I have my session keys. And these are the session, this is the session information here. If you go back to console, you'll see stuff that maps over directly to that. Basically, there's this activation that happened that that is saying I received the join request and I sent down the join accept, and now this session was created. And now I'm just getting these heartbeat packets. So that's good so far. There's this feature we changed this week, in case you're not familiar with it. It's called Debug. Basically, we don't, for like different security reasons, we're careful about not capturing your data in console and just making sure it just flows through to your endpoint that you've configured. But when you're developing, it's useful to kind of see what is happening. So we have this debug mode, which kind of breaks that, or it makes it so the payload does show up exceptionally. So only when you're logged in with a session would your payload actually show up on console. So this is what you'll see when you do that. And what's neat about this, so you'll see like dev adder right here. This is precisely what the device was showing us here. And so anyway, this helps with debugging different things about your packets and your payloads. You'll see frame up, frame down. That corresponds, actually, so frame up corresponds to F count. And it's basically counting your packets going up. Frame down counts your F count down. So those are your messages from the server down to your device.
And I think, sorry, Lewis,
go ahead.
I think you mentioned it, but the debug will give you 10 packets by default. Is that how it works?
I did not mention, but yeah, it'll maintain a buffer of 10 packets here. So I'm only 5 deep, so it hasn't filled up the buffer yet. But then once I get the 11th packet, it'll drop off the older one. The other things I wanted to point out here, it shows all the hotspots that received the packet. So I only have one that's right next to my thing, right next to my sensor. And it gives me all the information about the signal strength, the signal noise ratio, and then the frequency and the spreading factor used. And then the other thing in these debug packets is it tells you about the channels that it sent, or the integrations that it sent the packet to, and what the response was and stuff like that. But we'll see more of that in a second. I think that's all I wanted to cover for debug. So just to recap, where are we in the flow? So we basically we've done this top part. We have this stuff showing up on console, which is really just kind of a window onto the router, letting you know what's happening with the router. And now I want to connect it to AWS IoT. And that part's pretty fast. The only thing you got to do is create an identity that lets router kind of create and manage a device for you. I'm going to delete this and recreate it to show you. So you basically just name it whatever. You say, I'm going to give it programmatic access. And there's an existing AWS IoT policy that exists in AWS by default, and it's config access right here. And so that's all you got to do to create, to like basically set up the permissions for the integration. You'll want to write this stuff down because the secret access key won't be accessible after I leave this window. But that's what you're going to use here now when you go to AWS IoT Core. Let's go back here, get the access ID, get the secret key, and the region I'm on. I thought it was up here. I guess we'll go back to IoT Core. There. So I'm going to do everything on US East 2. And I'm going to call my topic button. Oh, there you go. Create integration. So the integration or channel is basically, it's like a data pipe, essentially. There's this extra construct called labels, which are a little bit more of an abstract idea where, actually, I'll call it like disco board. And these are, what's nice about the label abstraction is you can kind of connect a bunch of channels or integrations to the same label. And so it's just easier to kind of move things around and manage things. So I created the label disco board, which presumably I would attach to all my disco boards. Like I'd have one integration for the button pressing. I might have another one for the sensors, so it could go to a different endpoint, for example. But
And it's before I forget. So it's worth noting that all that stuff is accessible over a soon-to-be documented and released console API. So if you attach labels to something inside of console, you can actually access it programmatically via an API outside of console itself.
yeah, the API, which we're in the middle of documenting, but you can also touch it with the CLI, which is already released and documented. Very similar feature set. But anyway, so here we are. I did the integration. It will take a minute to show up, so we're going to go ahead and move with other things. You'll see that the next packet didn't quite show it, but we're going to get ahead and basically eventually it'll show up in AWS IoT. Let's see. We're here. I'm going to go ahead and jump and start doing the Lambda function while I wait for it to sync. Because basically when I'm in console, I'm configuring router, and right now the connection is a little out of sync, and it takes a couple minutes for it to sync up. So while that's happening, I'm going to go set up my Lambda function. And Lambda functions, if you don't know what they are, they call it like serverless code. And it's pretty neat because you can basically process the data, do something with the data, and you don't have to bother with running a server. And that's how we're going to do this integration over to Twilio. Now let's just take a second. All right, so now we're here. I'm doing it in Python. They all have the same kind of structure where the event ends up being the message that's coming in, and the context, we'll gloss over that for now, but it can be useful for other use cases. There's a lot of docs on AWS that'll tell you more about that. But so the code for this Twilio thing is over here. And I'll talk you through it real quick. Basically, it's going to look at the event coming in. It's going to look at the payload, and if it's that one that I showed you earlier, it means that it's the button that got pressed, and we'll send we'll do this post to Twilio with a text message. And then if it's not a one, it's that heartbeat packet, and we don't really do anything with those. So that's the basic structure. I have a bunch of like variables up here at the top, which are I'm going to configure using the Lambda's environmental variables. And the reason you do this is just to make your code a little bit more portable, and you can have a bunch of different Lambda functions here for different people that you want to alert, and you have the same code here by doing this. So I need to configure all of these. I'm going to keep it like this. So most of these are actually just taken straight from the Twilio interface. So I'll go ahead and do that. I'm going to get the account SID. You set these up down here on AWS. Oops, that was my account SID. I'm going to do another one. The auth token. And the other one is the assigned number. That one's a little bit harder to find. So this was my first time using Twilio in a while, and just as a reminder, if you've never used it before, basically when you set up your account, they give you a number from which they text you, and that you need to provide that when you're sending out the texts. It will not accept your request if you do not do it that way. The Twilio assigned number. And then the last thing is, who am I sending the text message to? I call that the user number. And I have this Google Voice set up here, which we will use because it's easy for you guys to see what happens. All right. So that is it. Twilio is also pretty cool because it's flexible on these numbers. I can present the number in lots of different ways, and it will accept it. So that's the function. It's all ready to go. Console has hopefully connected. It has not yet. Darn. Okay. What else do we have to look at here? So we just did this. Once the data is flowing here, then I can set up the trigger. That one's blue. There, okay, just in time. So at this point, the data should be showing up. Before I connect it, I'll show you one thing that's nice to know about on AWS IoT, which is this little debug window. I have a little bit of a backwards way of finding it, but once you get there, I'm sure there's a slicker way of getting to it, but this the Mqtt Client, that's what it's called. And if I do this pound, it basically will give me every single channel that is being posted on channel or topic. I'm kind of using those interchangeably, but basically, and there's the packet actually. So just to be clear, I set up this integration called AWS button. It's posting to the button topic, and now we're on AWS IoT. I'm connected to it, and you'll see that on this button topic, I'm now receiving the data, and it's just flowing through, which is cool. There's the name of my board, the identifier, all that good stuff, and the payload. And before I do any more, actually, I'll show you how the payload changes when I press the button. I just pressed it. Next packet in should AQ. There you go. It worked. So the data is flowing, and now I have to solve the problem of getting it to show up in my Lambda function. So that's where the trigger comes in. And the trigger, this is what I really like about AWS, is like moving data around their stuff. You don't need to be too sophisticated. It's super easy to get up and running. It is expensive, but when you're trying to just prove out an idea, this is really great to build an app this fast. So I'm going to just do my button thing, send text on button. Actually, it's a trigger, so capture all button messages. And then the query statement, they have an example here, which is pretty close to what we're going to do. Yeah, they like buttons over AWS too. That's pretty much it. Now it's all connected. And if I go back and actually, let me see, I think I have to go here. So watching monitoring is this window here takes a while. It looks like I got hit already maybe. But I prefer this view because it's pretty immediate. And I think, let's see. Yeah, so just know that when you're using CloudWatch, it's not super synced up. Let's just go through it again and see if I can get monitoring. All right, well, let's just test it. I've never been good at figuring out that stuff. So we'll go to devices, we'll see the data's flowing in there at least. And I'll go ahead and do the debug mode because that's easy. And what you'll see, hopefully, once I press the button is actually it'll send me that text message. And if not, we'll try to debug it. So I clicked. Let's watch the whole thing actually. So the async send happened. TX complete. I think debug mode crashed or something this time. Yeah, it looks like that packet went, but it looks like my my console had frozen. Let's try that again. So there's the AQ. It sent it to the endpoint. That's good. And CloudWatch isn't triggering, which makes me think that maybe I made I might have made a mistake with my trigger setup. So actually, just to show you one cool feature while I debug this. So what's nice is, so I had this this AQ that I know is supposed to be the button press payload. I can actually test the rest of my stuff to see that, like let's say I'm trying to figure out and debug what's happening here. I go to my Lambda function. go to my button alert, and they have this cool thing where you can rig up a test. So I'll actually just do that. I know this event represents a button being pressed. So I'll put this here. I'll create it. And now when I do that test, it'll run my Lambda function, but it's injecting that payload that I just kind of invented there. And if I did this right here, oh, it's because I didn't do save. All right, let's do that again. So now it did the button press message sent. I'll get the text message here. And let's delete that and do it again. This time I'm going to press the hardware. So let's go back to that view, press the button. It worked. It went all the way through, and we have another mistake probably. So let's go back and see that we did the rigging up of the trigger properly, because we know that this sends properly from IoT button. That was my mistake there. All right.
It's always the IoT button.
Yeah, well, I copied their rule, and I messed it up. Create new rule, button again. Really does get packets from button topic. And what I did earlier was I took their name, which was IoT button, but I called it button. There you go. Let's save. I think that's necessary. And this time, we'll do async send. Did I get the text message? Yay, there it is. So that was the
Nice.
demo. Actually, it's kind of good that it failed, because I found my two mistakes, which I forgot to hit save, and it allowed me to kind of show you this this test feature, which is nice. And just, yeah, so what is nice is you can kind of create more test events. So I'll do another one, which is button and not pressed, or I'll call it heartbeat. And that was just the AA payload. And that one just does nothing, but it lets you kind of test your whole app there, just as heartbeat. Anyway, so that's that. Just to recap, of what is useful to know is, so that was just data flowing kind of from an IoT device through the whole system there. Twilio does have a way to do data in the other direction, so you can literally build an entire application without even doing an app and just use simple text messages. And you know, that's really nice for doing something quick and dirty. And there's plenty of use cases where that's sufficient, at least to prove the idea of why deploy an IoT sensor and what is it doing for people. So anyway, that's it for the demo. I don't know what
Cool.
you're on to next.
No, it's great. I appreciate that. So that was pretty slick, and thank you very much, Louis, for demoing that. So I'll take the screen back over here, and let's see here. There we are. Cool. So we'll do Q&A in 1 second on that, but I do want to mention one thing, which I sort of teased at the beginning of this. So we just announced this competition that we're calling IoT for Good, which is specifically about harnessing the power of the People's Network, or the Helium Network, to help solve critical needs in today's society. And the focus is going to be COVID-19, but if there are any applications that people want to build that fall into this theme, we want you to be a part of it. So this is on Hackster, and I had the link here ready to go to drop in the chat, and I lost it. So the link is here, and whatever command that is not the right one. So there's a link to it. You should go, you should register, you should be a part of the contest. I didn't even mention this, but we're giving away about $14,500 US worth of prizes, both cash and data credits for the Helium platform. And we're also going to be having some free hardware giveaways from the various hardware partners that we have. So join the contest. Go be a part of this IoT for Good, and we would love to have your entry. You know, basically, if you're out building on the Helium Network, you might as well just be part of the contest. There's really no point not to. So with that, I'll open it up for questions. For people who aren't super familiar with Helium, I think most people here are, because I recognize a lot of names. You're going to want to start with chat.helium.com, which is our Slack channel with, I don't know, 1,300 people in it, give or take, and maybe 20 or 30 different active sort of sub chats inside of Slack, everything from node firmware development to sort of regional specific hotspot groups and everything in between. All the documentation is developer.helium.com, and github.com/helium is where all of our code is, everything that Lewis showed, plus literally hundreds of other repos where you can spend endless amounts of time. So if anybody has any questions, you can fire them off in chat or just kind of say them out loud if you're feeling daring. Otherwise, we can let you all back to your Friday. So I'll give it a couple seconds here to see if anything pops up. Philip, will this tutorial be saved somewhere online? Yes, this is being recorded. And I will send this around to everybody who registered. So you will have all of the content, Philip, and probably tomorrow, I would say, or maybe Monday. I'll take the weekend off. Let's see, any other questions? Are the upcoming hotspots identical to the previous ones? There are some hardware improvements to those hotspots, but for all intents and purposes, they're going to be the same. Lewis, actually, you might know if there's any specific board improvements that have been made. I mean, there is a new component from Rack. We worked with the Rack crew to build a new hat essentially for the board. But anything that comes to mind, Lewis?
Nothing major that would really change performance drastically. I think the RF is slightly better, but nothing that's like, I mean, and there is the Pi 4 in there instead of the Pi 3 Plus.
Right,
but everything just kind of there's nothing. I mean, it's all moving in the right direction, but nothing that really changes it drastically that would kind of make me as a hotspot operator really care whether it's an old one or a new one. But a lot of incremental small improvements, but nothing to, yeah.
Cool. And the price is much more favorable in the first batch, right? 350.
Yeah,
US
I mean, that was the real
495.
motivation, I think, to doing that was to just us get better at making these more accessible and more affordable. And that's where most of the work went.
Yeah, and as Travis is saying, there's obviously no reason to replace your hotspots. The one that everyone's running now are just as capable as the ones that we're shipping starting in a couple weeks, and they all have the same impact on the network and all have the same ability to mine tokens. So yeah, no reason to think about upgrading. Anything else from anyone here? Cool. All right, so if there's nothing else, I'll give it a couple more seconds for people to splash in here. But thank you very much for your time. We really appreciate it. We hope everybody is, staying safe and is doing about as best as they can during this pretty crazy time. Quite frankly, it's a good time to spend some time developing on the Helium platform. So we're doing everything we can to put out a lot of good content and tooling. Travis, who's on this call, does run what we call H4, or is it 4H maybe? Helium happy hour essentially every Wednesday from, I think it's 6 to 7 Eastern, so 3 to 4 Pacific. You should definitely join that. It's just a nice, fun, casual chat with the community. People show their projects and sort of talk about everything hardware related and not hardware related. On that, we'll see you.
There are virtual snacks.
I'm sorry?
There is virtual beer and virtual snacks.
Yes, yeah, virtual beer and snacks, which you can't really put a price on. So we'll see you wherever we happen to see you. I am Mark at Helium. This is Lewis at Helium, and the whole company and community are here to chat whenever needed. So we'll let everybody go. Happy Friday.